Greetings. This is Graham Warren working with you on an AnyLogic model for a Jackson network. So we're going to be building an AnyLogic model for this tandem queuing network comprised of two MM1 queues. This network has a mean waiting time in system of 0.15 hours. So we have arrivals coming in here at the rate of 10 per hour. These folks get served at the server here. There's a single server, get served at the rate of 20 per hour, enter this waiting line here, and get service here at the rate of 30 per hour. And this essentially just summarizes what the waiting time in system is, 0.15 hours. Right. So the intention with this playlist is to build a full AnyLogic model and sort of do a stream of consciousness to allow you to see, what my thinking is at least, and I'm certainly not a professional simulation expert, what my thinking is in the creation of this model, adding statistics to it and an animation, and hopefully getting us a result that is similar, although likely not exactly 9 minutes for the waiting time in system. I've provided a fully crafted model, so our model is not going to look like this exactly. It's going to look roughly like this as we go, but you are provided with a working model in case you struggle to replicate what is going on here. So I want to go ahead and create a new model. I'm going to call it demo. And I want to set up the model time units in minutes because, you've just seen me refer to the waiting time in system using minutes, the 9 minutes. Let's go ahead and finish that. Should get a new a little space here in the project palette. I clicked on that. There's the project panel, excuse me. And we have demo sitting right at the top here. So you've got the main, which is where we're going to build our model. And then you've got two other screens here that allow you various controls over the simulation. Just a couple other things about what we're seeing here. The properties of whatever palette you're in, or or maybe some of the modeling blocks will appear here. We're going to be manipulating parameters of our model here at various times. There's a toolbar up here. By far, the most important button is likely the run the model button. And then there's a palette panel here, which allows you access to various modeling components. AnyLogic allows us to build models, agent-based models, discrete event models, and systems dynamics models. In this course, we're only considering discrete event system models or process models. And so our most important block is going to be this one at the top here, the process modeling library. And I think we're going to mostly, in this particular model, use some of these blocks. We're also going to come back and do some analysis and space markup when we put the animation, add the animation to our model. Right, so just a nice thing about AnyLogic is as you hover over these things, you can get some help, some directions as to what is involved. Okay, so going back to our objective, I'm trying to set up two MM1 queues in tandem, simulate that. Let's dive in. So we're going to create customers here, and you can go ahead and relabel this block. I'm just going to call this customer arrivals. Now, we know that they come in at the rate of 10 per hour, so I'm going to do that. There's 10, and here's per hour. Okay. Now, one of the interesting things about AnyLogic is if you just use rate, then it's assuming that you have Poisson arrivals, which is consistent with our Jackson network. A Jackson network has Poisson arrivals. All its external arrivals are Poisson processes. And you can think of our particular Jackson network as two MM1 queues in tandem. So, the arrival process to the first one is a Poisson process, and that's consistent with the assumption made by AnyLogic. When you use a rate here, you're assuming force on arrivals. There are other options. You can put in, for example, normally distributed inter-arrival times, or gamma, beta, some other distribution. That'd be fine. And then there's some, more sophisticated tools to create arrivals. One of the things that may be interesting here is, in the personal learning edition of AnyLogic, you're limited to 50,000 NDs, or customers in this case. So I'm just going to plug that in there. It's not going to be relevant, but you're going to find other ways of not running up hard against that limit. But that would be, one way to sort of not overrun the license limit. Okay, so we've got arrivals coming in. What we're going to do is we're going to push them into a queue, because they've got to land somewhere, right? So we'll just put a queue in here. So I just grab that, and you can stretch it out. I like to get it on the canvas, and then we'll just stretch it out a bit. Let's do that. Now here you have a capacity, and it's currently 100. Don't think we're going to have a problem with that, but there is a limited capacity in this queue, so let's just leave it at 100 for now. If we need to come back and revisit that number, we certainly will. And now we're going to have our first service, and we're going to implement that using this delay. Now, what I want to do is I need to implement an exponential service time, because it is an MM1 queue, and I'm going to say it's got a mean of 20 minutes, 20 hours, 20 per hour. Okay, so that's how I implement that. This is the rate of the service, so 20. And I probably want to make that, let's see, I think 0 and 0. I think that's what I want. I'm not quite sure what these parameters are. Let's just go ahead and have a look at our help. Just make sure that we know what we're talking about here. Exponential. So it is a truncated distribution. Do I need that? Probably. So double. Okay, that's a lot of language. Let's just see if I go back one and just have a look at exponential. I think this is the one I want. Yeah, so I just need, so the minimum is so it's lambda, which is the rate, which is 20 per hour, and then a 0. So I think I can just implement this as 20, 0. I don't need the second 0. Good. And we're going to have a capacity of 1, because we're only going to be serving 1 customer at a time. All right, so what we've implemented now basically is we've got customers coming in, and we've implemented this part of our network. So we're just going to put a second queue, and then model the service as a delay, and then they're done. So we're close. Let's bring in another queue here. So I like to land it because you can see it automatically puts the arrow in, and then I stretch it out if I need more space. So let's crunch this up just a tad, get the delay in there. So I'm not going to touch the capacity on this guy. It is 100. Revisit that, as I said. So this is Q1. So let's just maybe relabel these things. Q1. Let's change Q1 to Q2, just to be clear. And then this is delay 2. I want an exponential 30 here, because the second one has a processing rate of 30 per hour. So you put the rate in there, the lambda, and then I just want to put a 0 in here, because I don't want negative times, and this is going to be per hour. So I just want to get this tuned up here to hours. Okay, so I think that's good. And I want to just label this one appropriately 1, and delay 1 as well. So hit enter and just delay 1. Okay. So, part of this process is to show you, the difficulties that may arise as I try to get this thing working. So we may have some issues with the debugging. Before I can run this model, I need to put in a sync block. This is just where good customers go to die, essentially. So once they've completed processing, then they just dispose of it. So we'll just call that sync. And I'm going to run this just to see if it fails, and we'll look at the debugging piece of it. But it's not going to do too much for us. Let's run this. Okay, I think I may have another. Yes, okay, it's going. And I can speed this up a little bit. Okay, so you can see some action here. You can see they are getting through here. So 10 have arrived, 7 have left. You can see there's 1 in service. And there's 10 have arrived here. 14 have arrived. 14 have departed. So yeah, the folks are moving through the system. We can see 21 have completed service. We can speed this thing up here to 50 or 100 times the speed of, where a minute in simulation time is equal to a minute in real time, our time. So now we're running at 100 simulated minutes, presumably per our real minute. We can control how far we want to go with this. Click on the ellipsis. I could say simulated to, say, 20,000 minutes. You want to hit enter, make sure it's in red there. And then this little double arrow just allows it to fast forward all the way to the end. So I'll do that. And you can see I only actually had 3,380 customers by the time I got to 20,000 minutes. It's a fair amount of simulation time. And of the 3,380, 3,378 completed. There are 2 folks still in the system. One's in service at delay 1, and one's in service at delay 2. But I think you can agree that not particularly interesting, because I don't know anything about how long it's taking them, how long the queues were. I don't have any real statistics. So we'll do this. We'll take a look at that, try and populate our model with some statistics, and then start verifying whether what we've built here is a match with our queuing analysis. Okay. So I'll see you in the next clip, and we'll do some statistics and histograms.